So today we're going to begin the Unit 3 test review. Question number 1 is dealing with what kind of numbers? Imaginary numbers.
We're going to do all these in order.
In this problem, we see an addition sign in front of the second imaginary number. Because it's an addition sign, we can just drop the parentheses and then start combining like terms. If this was a subtraction sign, we have to be real careful because we would have to first distribute the negative across these two numbers. So we're going to drop the parentheses and combine like terms. So we have 13 minus 12i. A note. The question asks us to simplify. Is this fully simplified? Is this simplified? It is, because it's in the general form of an imaginary number. The general form for an imaginary number is a plus bi. What's our a?
13.
What's our bi? Negative 12i. So there's no more simplifying that we can do here. Final. Number 2. Minus 3 plus 8i minus 4i minus 2. Well, we have a negative sign out in front of this parentheses, but because there's only a single term inside of the parentheses, we don't have to worry about distributing that negative sign to 2 or 3 different terms. And so we can directly drop the parentheses and just start combining like terms. So drop the parentheses and combine like terms. minus 5 plus 4i. Is this imaginary number in general form? Then this is final. Number 3. Okay, so we have the product of two binomials. They're binomials because each of these imaginary numbers contains two terms. And so we have the product of two binomials. There's a couple things that we need to know first, though. So some notes. Is I is equal to the square root of -1, and I squared is equal to what? So I squared is equal to -1. The first thing that we want to do here is distribute. Because we're not just adding and subtracting, so we're not just combining like terms. We want to distribute. So 7 times -1 is -7 plus 49i minus 2i plus 14i squared. So let's just combine the like terms that we're able to combine at this point. Simplify it just a bit. Plus 47 I plus 14 I squared. Well, we know that I squared is equal to -1. So we can make that substitution now. So -7 plus 14 times -1. And now we can combine those like terms because we got rid of the I squared. And so we have -7, and a positive 14 times -1 is just a -14. And so this is going to be -21. So -21 plus 47i. Is this in general form? Then we're done. Number 4. So number 4 is -3 minus 7i squared. What do we notice about this here? So it's a square of itself. Exactly. And so what we have here is we have to expand the binomial. And so this is going to be minus 3 minus 7i times minus 3 minus 7i.
I thought it was always like minus 3 plus 7i and minus 3 minus 7i.
Well, what this is saying is that this particular imaginary number, it occurs twice. It's the same number that occurs 2 different times. And so we just multiply it by itself. And now we have to distribute. What this is also called, you guys may remember from Algebra 2, this is called binomial expansion, right? Expand the binomial or binomial expansion.
That's when the 2 middle ones cancel out all the time, huh?
A squared plus 2ab plus b squared. So our a is negative 3 and our b is negative 7i. So technically we could just plug it into this little formula right here, but we don't have to really memorize anything. We know we have to distribute. And so if we do distribute this thing, then what we have is minus 3 times minus 3 is 9. Minus 3 times minus 7i is plus 21i. Minus 7 times minus 3i is going to be plus 21i. And then minus times minus is a positive, and then we have 49i squared. So plus 49i squared. Well, we know that I squared is equal to negative 1, but let's go ahead and just get these out of the way first, and then we'll make our substitution. Plus 49 times negative 1, and now we can just add these two together. So we have negative 40 plus 42i. Yes. A tendency at this point for a lot of students is to do what I'm about to do. But I'm going to warn you this is what you don't do. Yes, Sean?
Would it be wrong if you had 42i minus 40?
It's not wrong, but why is that not proper?
Because
Not A plus BI.
It's not in general
A
form.
plus BI.
Right. The general form for an imaginary number is a plus bi, not bi plus a. But you could write it that way and you'd be fine. It's just not the most proper way to write it. Don't do this. Do not. Why do we not want to factor out a 2?
It's not the right form.
Because it's not in general form. So a lot of students want to simplify this by factoring it out. Yes, if you were just dealing with x's and y's, then you would factor it out, like you always do, and you've learned to do. But because it's imaginary number, leave it in its general form. So do not factor anything out of this. We're going to leave it just like this. This is final in its general form. Number 5. So number 5 is going to be minus 3 over minus 7i. Minus 3 over minus 7i. What's our objective with this type of problem?
Get it out of the number.
To get the I out of the denominator. Right? So step 1. Is get negative 7i out of denominator. It's not just negative 7i. It's whenever you have a problem like this, you always try to get the i's out of the denominator, okay? How can we do that? Exactly. So we can multiply by negative 7i over negative 7i, but essentially what we're doing is we are multiplying by 1. And we're going to let 1 equal negative 7i over negative 7i. This is what property of our 9 fundamental properties? It's the multiplicative identity property. I've said this before, and I'll say it again. If you can learn how to master the use, when to use it, and how to use them, the properties, those 9 properties, you're going to be really, really good at doing math. Because most everything you do in applied mathematics, mechanical mathematics, procedural mathematics, applied mathematics, whichever one of those terms you want to use, they're synonymous, is based upon using one or more of those properties simultaneously. And so here we're using the multiplicative identity property. We're going to let 1 be equal to this because we don't want to change the value. We just want to change the facade. We want to manipulate it so that we can work with it. And in this case, what we have is minus 3 over minus 7i times this. Now we're going to multiply across. So multiply across, so we have positive 21i over 49i squared. Over 49i squared. Now, I squared is equal to what? Negative 1. So we can substitute. Now, is there a greatest common factor to 21 and 49? It's 7. The GCF, the greatest common factor, is equal to 7. That's the greatest common factor. 3 is a factor, but it's not the greatest one. So we're looking for the GCF here because we want to be able to reduce this down as low as possible. We do that by using the greatest common factor. Okay, so GCF is 7, and we can divide out 7 and make this into 3i over 7.
It's the opposite of the answer.
This is. Yep, we're just going to reduce this down. In this case, what is our A?
A is negative 3. 0.
Who said 0? A is 0. Essentially what we have is 0 plus negative 3i over 7. So we still have an imaginary number. Our A just happens to be 0. So this is final. The A and B's are always there. As a matter of fact, this is another interesting little thing. Every single real number that we have, pick a real number, anybody. 8? 8, the number 8 is also an imaginary number. What's our BI? 0. So the number 8, any real number, pick any real number, every real number is an imaginary number when B is 0. So pick any real number. 7 is equal to 7 plus 0i.
So 7 is 8. No.
So every real number is also an imaginary number. Okay, just like whenever we have an imaginary component, the real number component is always there, but what is it?
Humanity. Well, because
It's always there, but it just happens to be what number?
0.
0. Okay?
Zero is gonna be eight. Yes.
So every real number is also imaginary. And every imaginary number also contains a real number component. The real number component happens to be 0.
Every real number is
Number 6. What's our objective?
get the I from the bottom.
Get the I out of the denominator. So remove I from the denominator. How are we going to do that?
Multiply by
-1.
Not negative 1. Multiply by positive 1.
Where do you get one from?
I equals 1.
No, we're gonna use the multiplicative identity property, and we're gonna let 1 be what?
8 minus 4i. Over 8.
You always let it be the opposite sign of the one it is.
Negative
8 plus 4i over 8 plus 4i. So
We just do that for the last one? Or am I tripping? So for the last one, we must multiply by positive.
the last one, we didn't have to worry about a sign
Because it's not equal.
because there wasn't a real number component here. The real number component was 0.
Okay.
But whenever there's a non-zero real number component to the imaginary number, you must multiply, you let your 1 be whatever this is on the bottom with the opposite sign.
So you can multiply that by each other, by the other one.
And then the middles will cancel out. If you were to multiply this by the same sign, the middles would not cancel out, and you would actually reintroduce an I in the denominator. When you multiply by the opposite sign, you effectively cancel out all of the I's. So let's go ahead and and we are going to multiply across.
Which is going to be negative 24 plus 28i.
Or distribute. So
Huh?
So we have to distribute these out because we have two terms here and we have two terms over here. So we have to distribute these. So 8 times 8 is
64 plus minus
the new denominator is going to be 8 times 8 is 64 plus 32i minus 32i. Notice if we used the same sign, we would have had a minus 32i here and a minus 32i, which would have been minus 64i. They would not have canceled. This is how they cancel. So plus 32i minus 32i, that's because of the different sign. And then plus 16i squared.
I see what they did there.
Minus 16i squared.
Multiply that by -1.
But then when we add everything together, we have 64 plus 0 plus 16.
Why do you have to put the 0 right there?
Just to show they cancel out. But you don't have to. But now when we add this together, we have 80. So our new denominator is just 80. Okay? So let's go ahead and rewrite this. So we have minus 3 plus 7i
Over 80.
times 8 plus 4i over 80.
I'm confused. I thought this was already under the.
Yeah, that's why.
Oh wait, never mind. Never mind.
But now we have to distribute the top, okay?
Why did you do the denominator first? Just because.
You can do the numerator first, you could do the denominator first, however you want to do it, okay? So now we're going to multiply across or distribute across the top, okay? And so for here we have minus 24
Minus 12.
Negative 24. Oh yeah.
Minus 12i.
The new numerator is going to be minus 24 minus 12i plus 56i plus 28i squared. So when we start combining like terms, we have minus 24 plus 44i minus 28. And so then we can combine these. So when we combine like terms here, we have negative 52 plus 44i. That's our numerator. Now we have to put the numerator and the denominator together. So we have minus 52 plus 44i over 80.
We finished?
80.
80.
Or do you got it down there, Mom?
Now you can separate these out. You could put minus 52 over 80 plus 44i over 80 and then break down the 80. I'm okay with it like this. I would accept it just like this, okay? All right. But just be aware that on the challenge exam, you may have to fully break this down. And if we did fully break it down, this is what it would look like. So we're looking for our greatest common factors.
Which would be 20? No.
4 over here
Radius coming back?
and 2 over here.
You think
4 over here and 2 over here. So 2 over here, so GCF. Is it 4 for both?
yes, pretty much.
The GCF is 4 for both. So When we divide 4 into the top, we end up with 13. So minus 13 over 20 plus 11i over 20. This, now, do we have the general form of an imaginary number?
Yeah, pretty much.
Yes, our A is negative 13 over 20, and our B is just 11i over 20. So this is general form for imaginary number. This is final.
I like this better. Really?